Hey guys, I'm Carrie Wilson. I teach at Alvin C. York Institute here in Jamestown, Tennessee, and I wanted to put together a quick introductory video for this first lesson. I put everything into this slideshow so that there wasn't several things posted on Google Classroom. Everything that is underlined is either a resource, directions, or extra practice that you may want to look at in case you don't remember certain aspects or topics that are being discussed on the slides. The videos I would highly recommend watching, especially since they kind of go along with our STEM in Motion theme for this camp. This particular slideshow is about transformations of graph, although that's just an introductory type thing. We're not really focusing on looking at the equation and seeing how maybe the variable a might affect the graph, or the variable b in y equals mx plus b might affect the y-intercept, or different things like that. I want kids to maybe see how they're being affected through the Desmos activity, but it's just a quick introduction, and maybe you can use this lesson to kick off your lesson in Algebra 2 concerning parent graphs and the transformations that you can do with the parent graphs. So this lesson is more focused on having students look at different graphs. For example, a linear model versus a quadratic function, and having students really kind of identify, could this real world problem that we're experiencing, could it be modeled using a linear function, or could it be modeled with a quadratic function, or could it be modeled with an absolute value function? There's a lot of different parent graphs. To keep this lesson short, because there was a lot of review in case some of you don't know the topic very well, I only chose 5. You could probably choose more. It would be very interesting to hear what students might have to say if you chose more. And if they had a really good argument for why they chose the model that they did, honestly, I don't think that there is a wrong answer to this. I really want you to just dive in and have fun and just let your creative juices flow. Like, could this graph that I'm looking at right now, could it model the beam of a flashlight? And in our case, of course, we're doing STEM in Motion, the beam of your headlights on your car. Now, you can get in your car and do this, or you can get the flashlights that we sent to you in the mail, and you can, start playing with the zoom on this thing. And so if you'll look, I think I can do this. I'm hoping I can do this. You can kind of see behind me. See how big that beam is? When you're driving at night, you have pretty big beams on your car. Now, some of you have those newer LED lights, and so you may not notice this as much. I don't know. It kind of depends. But anyways, if you play with the zoom on your light, let's say I want to focus in on that spot on the wall where you can see the brightest point. I'm going to take and play with my zoom just a little bit, and you can start seeing, there we go, that the beam is becoming more narrow and more focused. And so I want you guys to think about, if you're a person standing in a position, and I'll kind of sketch this so that you guys can see what I'm talking about. I'm sorry, my little dog is very chatty today, and I can't get him to stop barking. This is probably my 10th take, and I just can't get him to stop barking. So, picture yourself as just a little stick figure holding the little flashlight, and you're, kind of shooting out these lights, and, you can see a certain focus. And this is not the best drawing. I am not an artist by any chance, but you can see the little stick figure holding the light. When I talk about how do we model this beam, you might, look at the beam in this direction. You might look at the beam over here on the wall itself. I'm hoping that you focus more on the beam part of modeling this. And so, again, going back to our flashlights, when you play with the zoom a little bit, and yes, I still have it on. So if you play with that, you zoom in more and more and more, you can kind of see, oh, there we go. Now your flashlight may become a square at this point. You've gone too far. You need to zoom back out. And so when you zoom back out, you can see wider, but can you see as far? And so that's kind of how your headlights on your car operate. you know, in the city, you don't need your brights on. You've got enough light that all you need to have on your car is your regular night driving lights. And so, what's the difference? I mean, seriously, think about that as a model on a graph. And how could you model that? And so play around with that. You've got a flashlight, and it's super fun to zoom on these things and go out after night, you know, when it gets dark outside, and go have some fun with this flashlight. I don't know why flashlights kind of amuse me, but they do. And again, think of it in terms of driving. There's people that do research on headlights on cars, and I tried to include some of those articles, and I hope that you guys find more links and you can include those on the slides. I would love to see what you guys come up with. So again, this is just a quick introduction to this particular lesson, the transformation lesson. And what I'm going to do now is I'm going to share my screen so that I can kind of go through these slides and just quickly point out some things that I did with the slides. So let me click the share button, and I'm going to take you right over to where the slides are at. Well, now I don't see them. They were up here, I promise. I had them ready to go. Here they are. So it should pop up here in a minute. I think you all should be seeing this with me. If you're not, we will find out here shortly, won't we? Anyways, here is the title slide, of course. If you look down here near the bottom, I'm trying to show you this with my little mouse cursor scooting across the screen over here. But I did this in highlighted yellow, really hoping to catch your eye. I have added many speaker notes throughout the slideshow, so be sure to look for these notes throughout the slideshow. I'm hoping that if you look at these notes, it might help you in case you get stuck. Like, what did Carrie want me to do here? Well, you know, just look at the speaker notes if you get lost, and that might help you. Or revisit this introduction video. Maybe it'll be less confusing to you once you start looking at the slides. And of course, I don't have my video in here yet, and so you're going to see this slide, you know, before I put the video in here. But you'll see the video, here shortly. Again, if you look down here at the bottom, I have the speaker notes, and I'm going to go ahead and make this a little bit bigger. In the following slides, and I bolded this and underlined this because it's kind of huge thing. In the following slides, all underlined text is hyperlinked. So if you see anything underlined, it's a link. You can click on it, and it will take you to a website that I mean for you to go to. And whether you find that website useful or not, make a note of it and put it in the survey at the end. That would be useful for me to know as well. If you would like to see or practice additional information about a certain concept, it is provided on their respective slides. You do not necessarily need to have the additional information to complete the parts of this assignment. It is provided in case you need it, or you might be a nerd like me and want additional information or resources or practice about the topic. And again, I focused more on the math, and at the end I've kind of scooched in a little bit of science so that you can have that. And maybe you'll find some more resources. A lot of you should be science teachers, and so you may have way better resources than I've included on these slides. And again, you guys can see, just, you know, go through the slides, look and see what's on here, and kind of explore it for yourself. I don't want to talk about every little thing and give every little thing away. But again, if you look right here, I want to make the slide bigger again. You can see that there is an underlined resource. So if you click on it, just click on it. You don't have to hit control click, just click on the underlined portion, and now pops up a hyperlink. So you click the hyperlink and it will take you right to the website. So let's say I don't remember what linear equations are. Math is Fun is a great resource. It's probably one of the best that I use all the time, especially if a student comes in for tutoring, because it basically goes back almost to the beginning of this topic, and it makes students go back to the beginning. Maybe it fills in a few holes that they're missing, and then by the time you get to the bottom of the page, and again, there's extra information in here too, but by the time you get to the bottom of the page, you will see some questions, and you can practice this too. I try to include all Math is Fun links and Khan Academy links, and if you think of any more links, please email me. It's cwilson@yaidragons.com, and that's dragons with an S, so C, Carrie, Wilson, at yaidragons.com. Just email me with some links and I'll put them in the slides as well, or you can include them at the survey at the end of this. And so again, you can click the links. You don't have to click the links. I'm going to exit out of this one and go back to the slides. And so you can kind of see I did all of the parent graphs for you guys to kind of review and look at. I put in different forms of the equation. Maybe you might find that useful, maybe you may not. I don't know, it's kind of up to you if you want to use that information. Here's a quadratic and different forms that it's written in. And again, you've got these extra sources in case you need them, exponential. But which one of these parent functions would best model a flashlight beam or the beam of your headlights as you're driving at night? You've got two beams going out in front of you and hopefully lighting your path so you don't hit a deer or a possum or even worse, a skunk. They're stinky. So anyways, then when you get to here, I try to be pretty clear about what you need to do. It's underlined, so we'll click it, and when we, oops, well, look at that, it's not working. So if we click it, it's a rubric for lighting up. So I created a rubric for this so that you can kind of get like a foothold. Where do I even start? Well, maybe you should use math vocabulary. Maybe you might want to include the graphical figure, because that would be a great thing for you to talk about with actual text and refer back to the pictures so that the reader knows exactly what you're talking about in case you don't remember or know the exact mathematical terms that you need to use. And this is a great kind of formative assessment to kind of figure out, what do my kids know about this topic and what do I need to teach, and different things like that. The argument length, this is how much they should write. You can change all of this. Once you get in here, you could probably change this. Please make a copy of this document. Don't change my document. That way everybody has the original. The argument composition within real world context. We want the students to really understand the standard that we're trying to get across, that they need to model the real world with mathematics. When I was a high school student, teachers would say, I see math everywhere. Well, I don't. Could you share with me what you mean by that? And so I'm really hoping that this lesson makes kids think creatively with math. I really don't want it to be, no, that's wrong. I really want them to think about, well, if I use an exponential parent function to model headlights, well, what part of that graph would go with this part of the beam, and where would I be standing, and where would the beam go out to, or would it go on for an infinity? Or maybe even students might want to make it a piecewise graph and cut it off at different points. It could be a very interesting argument that they could pull up, and it could be very creative. Maybe they combine graphs and do a piecewise that way. It's all creativity, and I don't think kids get to be creative enough in math, and so that's why I really wanted this to be kind of open-ended. So please have fun with this. Please don't stress about it. It's just going to be fun. Grammar usage, I have to put this in here because I need to be able to understand what you're saying, even though you're using, of course, math vocabulary. Sometimes when we don't put the comma in the right spot, we can have some issues. So try to follow grammar usage, of course, when we're doing this. And I modified this a little bit because, of course, this is your part A. You chose the argument based on these parent graphs that are static. They're not moving. It's just a snapshot. And so, I wonder if we make this interactive, maybe our choice might change. And so again, there's some notes down here at the bottom to show you how you need to name your document that you're going to be turning in. And this is only part A, so don't submit until you're done with part B. When you submit, you can't edit your own file. And so that's why you need to hold on submitting until you are done with both parts. And again, I put a stop sign here. Please don't work ahead. Please construct that first argument before moving on to the next part, okay? And then going on to the next part, of course, I'll get the video in here too, so you'll see that. And again, there's notes down there in the speaker note area. Here are the transformational rules. I actually put this in here. Maybe you will need that. Maybe you won't. But again, there's something underlined, so you'll just follow the link. And I say that, and sometimes it doesn't want me to click. Sorry about that. But anyways, this is a Desmos activity. I've already signed in, and so I'll go ahead and follow myself as being Carrie. And I'll just kind of show you, here's all the directions that you will need. You don't need to remember these because I tried to put them on additional slides. And by the time you get to the last parent function, I would hope that the directions are pretty much stuck in your brain. Here's the next slide, and you actually get to play with the sliders, so you can move the sliders any way you want to, or if you don't want to manually do it, you can push the play button and it will do it for you, in case you've not played with Desmos before. If you're really creative and want to get rid of the line altogether, you can click that, and if you do that on accident, just click the button, it'll come back on. I don't really think you can hurt this too much if you just play with the sliders or manually play with the sliders. Please try not to tap on the -10, which pulls this up. And if you do accidentally pull that up and mess with it, I don't want you to limit your creativity, but sometimes when you get rid of that, I don't know, it just stops working. So in case you do click on it, here's what it's supposed to say: is -10 is less than or equal to the slope of the linear equation is less than or equal to 10. And I did a stepwise of 1/100th of a unit. You can change that if you want to. It's all entirely up to you, but this is what it was set to. Both of them all of them are set this way. I don't know why that doesn't have 10 there. But all of them are set this way, and so you can just go back and fix that anytime. If you lose the formula, well, there it is. You can look up the formulas and you can apply the sliders if you lose the formula. Or you can click Control Z if you lose your formula. Let's say I accidentally erased this. Oh my gosh, it's gone. Hit Control and then Z. Control Z, you might have to do that several times because I really undid what I did. And so Control Z is starting to put back my linear equation that I need. And so now we're back to where we were before, and so now we've got our graph. So if you just keep clicking the arrows up here at the top for next, you just go on to the next slide, and so on and so forth. And you get to explore all of these graphs that were static before. Now they're interactive. And maybe you change your mind. Maybe you can improve your argument from before and not change your mind. That's what Part B is about. And so we'll go back to the slideshow. So for Part B, whoops, already been there, already done that. So for Part B, here's the rubric again. I put this in bright yellow because some of you might go, oh, she didn't put Part B's rubric up here. I did. It's very similar. I only changed one little part, so I'm going to click the link so that you guys can see what I changed. And you can add to this rubric. Again, if you decide to do any editing to the rubric, please make a copy of the document first so that the original is there for everybody. Some people don't like to change the rubrics. And so here's the new part. New material. This is Part B. You should have some new material. You either added a considerable amount of thought into the original argument and added new items to your argument, or you completely constructed a new, well-defined argument. And that would, of course, get you the most points. You guys are in a camp. We're not going to grade you. So please don't worry about a grade on this. I will be giving feedback. I like to think that I give nice feedback, but if I'm rude or mean in any way or something doesn't read right, please let me know. I can, discuss it with you, but I really try to give positive feedback, and I really want to model to you that this is meant to be creative. It's not meant to be hardcore. No, you got the answer wrong. There's only one right answer. I really want this to be creative. And so if you have a really good argument, you might be able to sway me. I have some thoughts in my brain about what should be the model. But of course, I've had a lot of time to think about this. I've been wanting to do this lesson for forever. And whenever I talk to my student, I'm giving you too much information. Let's move on. So Again, we're getting near the end of the slideshow. I try to do this on both of the lessons, is give you additional resources. I kind of went off topic as I was looking for like headlight videos on YouTube or headlight articles. Either the articles were like college level articles and peer reviewed and not something a high schooler would want to read, or they were more general. And I put the more general science links on the next slide. So you have those, and they're just based on light in general, but I really wanted something for how your car headlights worked, and so this one is a little bit more specific. If you can find more, please add them to the links right here on the side, and that would be just great. It'd be wonderful to have those extra resources for science. And I'm going to go down just a little bit further. Again, here's the stop sign. Make sure you turn in part 2 before proceeding, because when you proceed, I did this on both. You should have a survey, and please kind of reflect back on this, like process. Was there something that you thought, well, a student might stumble here, maybe she should give more information or less information, you know, different things like this. It's hard to create something virtually when I've, you know, taught in the classroom for the past 7 years and never had to do anything virtually. So if there is a gap somewhere, please let me know in the survey, and that way I can kind of improve for next year in case we're online again next year. I hope that we're in person. That'd be wonderful. So again, please fill out that survey with some thoughtful feedback about the lesson. And then here's the next one. Here's the actual lesson plan. Again, it's underlined just like the previous slide. Just click on the link and it'll take you to the actual lesson plan. This is a lesson plan. I don't like that 22nd there. That's weird. Let's get rid of that. So here's the actual lesson plan that I tend to use to turn in for my evaluations at my school. And if they ask for lesson plans to be turned in, this is what I tend to fill out. My goals for the lesson plan, learning objectives. This one actually had a main objective and some, you know, kind of additional objectives that snuck in there as I was putting this together. And then prior learning, purpose, rationale. Here's the standards that you guys are most interested in seeing, of course, if you're a math teacher. I have a hard time finding the science standard that I need. I really should start like looking through those science standards a little bit better, but I'm a little crushed for time. I'm taking 3 classes this summer, and time is very limited right now, so I apologize for that, that I don't have a science standard. Maybe we'll get one thrown in here before Stride starts, and that way you might get that science standard. I'm not sure. Here's what you would need to prep if you got to do this in your classrooms, and then your resources, materials that you might need. And of course, for the student, they would need to have internet access unless you decide to show this on your classroom projector for all the students to kind of move at your pace. It's just kind of how you would do it. Of course, here's your procedures. I've kept those very short. You can add to it. Of course, make a copy of the document and add to it with the original as is, if you don't mind. Here's adjustment for individual needs. And what I really like to put in this area is, you know, maybe they could, you could push your early finishers and have them come up with some other real world transportation problems that they could model using these parent functions. You know, maybe something crossed their minds like miles per gallon could be modeled using a linear equation. We know that, but they might never have thought about it, and they might come up with that on their own. And how powerful would that be? You know, they saw the graph and they thought of, miles per gallon is pretty linear looking if you think about the data. So, you know, something like that would be very, very cool, very interesting. And then, of course, here's your assessment or method of evaluations. There's probably more in there. I just, again, kept this kind of very brief so that you guys could add to it if you would like to use it. That'd be wonderful. Here's the resources. I think this is the complete list of resources that I used in the slides. The slides are the most comprehensive part of this document. Just go back through there. Anything underlined is a valuable link, at least valuable in my eyes. And if you wanted to use these slides, you are more than welcome to. Just take my videos out of the slides if you don't mind. I really hope that you enjoy this. And again, if you have any questions as you're working through this, please email me. Again, my school email is cwilson@yaidragons with an S at the end.com. And so I look forward to hearing from you all if you have any questions. If not, I look forward to reading your submitted documents and giving you some feedback. Have a fun time. Bye-bye. Well, if I click stop share, maybe I could say bye-bye. I have moments.